In my last few projects, I used up most of my 8mm shafting, so today I'm going to take apart this printer to get some more, and I thought I'd share this with you because every time I take one of these apart, I'm amazed at how ingenious they are. This one's actually an all-in-one printer scanner type thing, so first we gotta get the scanner thingamajig off. Oh, I guess I missed a couple of screws. Well, this piece of glass is still of use. And wow, look at the scanner. It is so minimalist. We've just got a little motor that drives the gear on here. It used to be these used to have a belt to drive the head back and forth, but they just put the motor on here. And it's not even a stepper motor, it's just a regular motor with a shaft encoder on the end of it so that the computer knows where it is. There's some wires going onto this thing here, and it looks like there's an opto sensor right here. So maybe I'll try to pop that apart. I'll save that one. So these buttons here have got springiness to them, and that's just part of the plastic here. There's no actual springs. Cute. There's a little estimated ink level bar chart right here, and those actually use little plastic light pipes to take the light from the LEDs on here, which are surface mount. Another clever little thing, there's a little bar chart sort of thing here on the panel, and that fits right in front of the slot here. So from the back, the scanner sensor can see this bar chart, which probably tells it a little bit more about what version of panel there is on the front. And here's the actual printer mechanism. Unfortunately, it's in this plastic tub, so I'll cut that off a little bit to have a better look. Not much electronics in the printers these days. The printhead on this thing glides on this shaft, which is about 8mm, and it's just driven by this very small belt, and there's a little motor on the end here, and this is not even a stepper motor, it's just a regular old DC motor. And the way the printer actually knows where the printhead is this has got some very, very fine bars of black and white, and there is opto sensors on here, so you can just tell as it moves from that. And that's a lot more accurate than having a stepper motor in the belt. And the reason it needs to be so super accurate is with these cartridges being offset from each other and all the color printing, you gotta know exactly where the printhead is so that the registration lines up from going one way and going the other way, and from one line to the next. This little clip keeps that sensor strip taut, and if I push it I can unhook it on the other side and get it out. This spring here pulls the shaft back, and that keeps it from wiggling around too much because consistency is key with these inkjet printers. And then there's a snap ring to keep this shaft from sliding out. So here's our nice polished 8mm shaft. And a little spring here to keep this cable down flat. Very clever. So here's the print heads, and they're leaking ink all over the place, which is why I'm starting to get some on my hand. But the other place that's full of ink on here is this thing here. Which, to make sure that jets on the print heads aren't plugged up, periodically the printer will move the print head over this area, which is sort of a spittoon, and it just fires the jets full force into here. And there's some felt pads in there to kind of absorb the ink. This has gotten all black from having gotten spit onto so many times. Another head cleaning function is this thing here, and these are actually little rubber squeegees, so the printhead moves here, and then these squeegees clean the printhead. At the other end of the printhead's travel, we have a pin here, and when the printhead pushes against here, these little rubber pads come up, and the function of these is to cover up the ink jets here to keep them from drying up. One thing I can't figure out at the moment is what used to power these squeegees back and forth. They don't at the moment appear to be coupled to anything. So here we have the motor for the paper advance, and that powers this thing here, which powers this here. And here we again have one of these shaft encoder type things, and there's the opto sensor down here, so that the printer knows with very high resolution how far the paper's actually moved. Down here we have a secondary set of feed rollers here, and these are coupled to the main one with the gears here. And the reason these are here is as you get to the bottom of the page, once you run off the bottom, you still need to be able to move that paper and get it out of the printer. And so these little wheels here push onto those rollers here and grab the paper once it gets off the main rollers. How does this come apart? Something's holding it on there still. Oops. So there's a bunch of gear assemblies on here, and I noticed there's a gear in here, and that seems to be coupled to the squeegee. And there's another gear back here, which is probably for the paper feed. So something or other caused these feed rollers to cause the gears back here to engage, and I'm not quite sure what that was. Aha! So I just noticed there's a little bit of plastic here which broke off of something I just smashed. And it looks like that fit onto here. And what that would do is pull this gear up to cause the gears in here to engage. And it looks like this whole assembly was meant to turn, and there's this interesting angle-shaped tab on here, which I'm pretty sure, oh yeah, that would engage this part of the printhead here. So as the printhead got off the edge of the range, it would rotate this thing a little bit here, and that in turn would engage the squeegee bit. Oh, look at that! And as that moves back and forth, that moves this little thingy here, which I'm not quite sure what that was, but it's probably something for the paper feed. And these little gears here would also engage with a whole bunch of gears here, which drive all these rollers, and this roller specifically is part of the sheet feeder. So probably by moving the printhead all the way over to here and driving the motor in a certain direction, the whole sheet feeder becomes engaged. So basically by bringing the printhead over here, the paper feed motor engages the squeegee here and also the sheet feeder mechanism, so they don't need another motor for that. This little tab here goes to an opto sensor here, which is probably there for detecting whether there's paper or not, the whole out of paper thing. And that could still be usable for something or other. So I'll take that out. It's pretty clever how it fits around all the plastic corners to hold it in place without clips. Maybe a bit too clever for me. I always save little springs like that. You never know when you need one. Lots of little gears, aren't they cute? These shafts are held in place just with little plastic clips, and just by unclipping that and rotating it a little bit, it should pop right off. And here's our main motor gear. I might just leave that together like that. Could be handy. Here's the shaft encoder disc, and I think I can save that. It's funny how much shaft encoders cost if you try to buy one separately. And here in a junk printer, there's one right there. I'll keep this motor and pulley assembly together. I figure it's more useful that way. So here's the goodies I'm keeping. An 8mm shaft. Bonus, a second 8mm shaft. All I have to do is get the rubber rollers off of it. A couple of shafts that are probably 6mm. A little DC motor, another DC motor, and this is the one from the scanner. And a bunch of opto sensors. The shaft encoder disc with the shaft encoder. This could be a linear encoder, but the other half of that is attached to the printhead PCB. And I don't think I'll ever use it. If I need one, I always know where to find one. Just smash another printer. So I hope you enjoyed taking apart this printer. I'm always fascinated with how much these printers achieve with so few parts.